Let's finish up with number 9, and let me remind you, please, if you do not show your work, you will get 0 points. 0. You will actually get 0 points. If you do not show your work, you do not get credit for anything, even if the answer is correct. I'm getting pretty tired of students saying things like, well, it's better than nothing. In fact, it is not better than nothing. It is the exact same as nothing. So, if you're not going to show your work, don't even bother, because I'm not going to give you credit. I hope you learn that. So number 9, what is the wavelength of electromagnetic radiation if its frequency is 3.2 times 10 to the negative second hertz? Okay. So we've been given a frequency, and we need to calculate wavelength. All right, so we're still going to use c is equal to lambda nu, but as opposed to number 8, where we're solving for frequency, here we're going to solve for wavelength. And so I'm going to divide both sides by frequency. So I end up with lambda is equal to c over nu. Now I'm still going to use the same value for speed of light, 3.0 times 10 to the 8th meters per second. And the frequency given to me by the actual problem is 3.2 times 10 to the negative second hertz. Now before we get into the actual numbers part, let me remind you that hertz is the exact same unit as 1 over seconds. 1 over seconds. It's the exact same thing. So in the numerator here, I have meters divided by seconds. Well, that means that I'm dividing a 1 over seconds by 1 over seconds. That means that hertz and 1 over seconds get to cancel. So the only unit that is left in this calculation is meters. And that would make sense, or should make sense, because we are calculating wavelength. The unit for length is meters. So I want to be straight there. Next, before we get to the easy part in the calculator here, okay, just dividing those two numbers, let's talk about the exponents. Remember, when you have two numbers that contain exponents and you are dividing those values, you subtract the exponents, right? You subtract the exponent on the denominator from the exponent on the numerator. So that ends up being minus negative 2. Well, 8 minus negative 2 is positive 10. Right? So in this calculation, I know that my answer should be a times 10 to the 10th meters. Okay, cool. Now I can actually carry out this calculation. Throw that in the calculator. And it gives me a bunch of gobbledygook, 0.9375. Okay? And this is actually an appropriate value. It really is. However, it's not in proper scientific notation, and it does not have the appropriate number of significant figures. So I need to figure both of those things out. Let's stick with the sig figs. Right? Looking at the question, I've been given information that has 2 significant figures in it. So my answer needs to have 2 significant figures in it. So that means that the 9 is the first significant figure, the 3 is the second significant figure. So looking behind the 3, I see the 7 tells me to round this 3 up. And so I'm going to have a 0.94. That's it. 2 significant figures. Next, I need to put it into proper scientific notation. And so that means I'm going to have to move the decimal 1 spot between the 9 and the 4. So I'll have 9.4. Now, my original exponent was 10, right? Times 10 to the 10th. But I had to move the decimal. And again, using my conceptual method, this number right here, as it's written, is less than 1. This number, as it's written right here, is almost 10. So you can tell that this number got, when I moved the decimal, as a result of me moving the decimal, the number got bigger. Well, that's not allowed. We can't change the value of the expression, so we have to balance out the fact that this number got bigger by making the exponent smaller. Okay? So you can already tell I moved the decimal 1 place, and so I'm going to have to change this exponent by 1. The question is always, well, is it 1 bigger or 1 smaller? Remember, this first part of the value got bigger, and so in order to balance that out, the exponent needs to get smaller. So my final answer that I report is 9.4 times 10 to the 9th meters.